All right, today we're going to be solving multi-step equations and inequalities. We have the same exact goal that we did for one step, and that is to isolate the variable. We're going to do that by using inverse operation. The only difference is that today it's not going to be one step. We're going to have two or more steps in order to figure out the solution or solutions. So example one, we're going to solve this using two steps. The process is the same whether you are solving for an equation or an inequality. All right, so our goal is to isolate the variable of x. In order to do so, we need to use inverse operations. And we're going to kind of start outside in. So the first value that I want to use the inverse operation of is 13. The opposite of subtracting 13 is adding 13, and I'm going to balance my equation by adding 13 to both sides. So I'm left with 2.5x is equal to 15. A number right beside a variable means multiplication, so I'm going to do the opposite and divide by 2.5. And x is equal to 15 divided by 2.5, which is 6. Now, to review the last lesson that we just did with graphing, since it is an equal sign, that means that there is one solution. So on my number line, I'm going to locate 6, and I'm going to have a dot that is closed on 6 to represent the one answer of 6. Now, when we solve inequalities, the process is exactly the same. I'm going to start by adding 13 to both sides. So 2.5x is now greater than 15 since the inequality changed. And then the opposite of multiplying is dividing. I do not have to flip the inequality because the value that I am dividing by is positive. So it remains the same, and x is greater than 6 is my final solution. When I graph, since I'm graphing an inequality, I have to represent all the solutions that it includes. I'm going to have an open circle. Since there is no equal sign, 6 is not included. And then I'm going to shade in the direction that represents all numbers greater than 6. So that is 7, 8, and everything to the right. Our second example includes combining like terms before we even start. So we kind of want to clean it up. We want to make it a little bit easier on ourselves. In order to do so, we combine the y's together to create only one variable. So 9y minus 6y is 3y. Then I'm going to rewrite everything nicely below it. And then I'm going to solve exactly how I solved before. So my goal is to isolate. I'm trying to get this y by itself. I'm going to start with the opposite of adding 15, which is subtracting 15. So negative 27 is equal to 3y. And then my last step is to divide each side by 3. And y is equal to negative 9. Since this is an equation, there is one solution. So all I have to do is represent that with a closed dot on negative 9. The process for solving for inequalities is exactly the same. I'm going to combine my like terms first, just as I did before. The only difference when I rewrite my work, I'm now rewriting an inequality. 9y minus 6y still combines to 3y. The plus 15 drops down. Same two steps that I did right over here for an equation. I subtract my 15 from both sides. So I have negative 27 is greater than or equal to 3y. Divide each side by 3. Because I am dividing by positive 3, no flip is necessary. So I'm left with negative y is greater than or equal to y. Sorry, negative 9 is greater than or equal to y. I like to rewrite it in terms of y, or a variable, so y is less than or equal to negative 9. This time I'm going to have a closed circle because of that equal to sign, and I need to represent all values smaller or less than negative 9, so that's going to be negative 10 and all numbers to the left. All right, our last example is going to use the distributive property in order to solve the equation or inequality. That set of parentheses means that the outside number needs to be multiplied through to both numbers on the inside. The distributive property uses multiplication. So I'm going to multiply 2 times 1, which is 2, minus 2 times c, which is 2c. Everything else is going to be copied. Now we're going to use what we just learned in our last example. We're going to combine like terms. We can put together the 2 and the 3 because they're both constants. So 2 and positive 3 combine together to make 5. My negative 2c drops down, and that equals 8. Finally, since everything is cleaned up, our goal is to get the c completely isolated. The opposite of adding 5 is subtracting 5 from both sides. Negative 2c is equal to negative 13. And then I'm going to divide each side by negative 2 because the 2 or the negative 2 is right beside the c, which means multiplication. And the inverse of that is division. So c's final value is 6.5. So to graph an equation, I'm going to locate 6.5 on my number line, which is halfway between 6 and 7, and place a closed dot on 6.5. When we go to solve the inequality, the process is exactly the same. So we're going to start with the distribution property, which we still get 2 minus 2c. Everything else drops down, including the inequality now. We're going to combine like terms, just as we did with the equation. So negative 2c plus 5 is less than negative 8. I subtract 5 from both sides, just as we did before. So negative 2c is less than negative 13. And I divide negative 2, just like before. The only difference now is since I am dividing by a negative value, my inequality does flip around, so it's going to become a greater than symbol. So c is greater than 6.5. When I go to graph, I'm going to have an open circle at 6.5. And I'm going to shade everything to the right to represent all of the greater values.